In this part, we'll refine the login form and go into low-level graphics for animation and background. This is how I finished the previous part. I discussed the fonts, but there are other differences. Obviously, the flag is slightly different since I used our own resource file. But there are two other noticeable differences. The first is the drop shadow behind the logo, which is missing. The second is the background rotation of the pattern, which is iOS specific in the native app, but I don't see a reason for that. I'd like to have it on Android too. The simplest thing to do is generate a square image of the logo that already has a translucent shadow within. This would be pretty trivial to anyone versed in Photoshop and would look great on the device. However, my goal is to teach programming, not Photoshop, so I'm picking the hard way of solving this. The effects class in codename 1 allows us to create a shadow image for the given dimensions or image. Since the logo is square, we can just use the dimensions approach. The method accepts the size of the shadow, the blur radius, which means how far it should go out of the size limits, and the opacity as a value between 0 and 1. So now we have an image of the shadow, but the logo image and the background are already fixed, so we need something new. Instead of using the logo as it is, we place the shadow in a layer below using the layered layout, and this will produce the desired effect with one huge caveat. It's really slow. Shadows are computationally slow. We use Gaussian blur to generate shadows, and that's a very slow algorithm. The solution is to move that code offline. The UI will appear and the shadow will appear a second later when it's ready. The placeholder is there so we can put the shadow into place when it's ready. When the shadow image is ready, we replace it on the EDT with the new shadow label. The label uses the container UI ID, which is always transparent with 0 padding and 0 margin. The Android version of Uber doesn't include the rotation animation for reasons that are just unclear to me. I think it might collide with some of the material design transitions or some other problem. It works nicely on all OSs with the way I implemented it. I could just rotate the tiles like the one pictured above and call it a day. The effect would look decent and perform well. However, I wanted better control, and in order to get that, I need shapes. Shapes allow us to draw arbitrary vectors, curves, in a performant way. Since this is effectively a vector API, rotation and scaling don't distort the result. In order to use this API, I need to use the low-level graphics API and the background painter. We can set the painter for the logo object using this code. Notice that normally we don't need a reference to the parent component logo, but in this case we need it for the animation. I'll go into that soon. But first I'd like to say a few words about painters. Styling can only go so far. If you want to customize the background of a component in a completely custom way, you can use the Painter API to define the actual rendering of the background. This overrides all style rendering and provides you with a graphic object you can use for drawing. Notice that the graphics API is a low-level API and might have platform-specific behaviors that aren't as refined as the component style APIs. It's harder to optimize low-level graphics code, so use it with caution. Now that we got this out of the way, let's look at the Painter code itself. This is the rotation angle in degrees. We increment this as part of the animation logic. This is the shape object representing the background pattern. We draw it or stroke it like a rubber stamp. The constructor and the draw shape method create the pattern shape that we stroke later. This code happens once to generate the lines, and we then color them later on. The register animated method of form is needed for low-level animations. It triggers invocations of the animate method with every EDT tick, so we can update the animation state. In this case, we change the rotation angle with every tick. The draw shape method adds logical lines and quads to the given path. A quad means quadratic curve to the given position. You can see three methods used on the path element. Move to moves the virtual pen in the air without drawing anything to a starting point. Line to draws a line from the last position of the pen to the given position. Quad to draws a quadratic curve, a Bezier curve, to the given position through the given curve position. The paint method is the callback from the painter. We fill the background, rotate the graphics context, and draw the shapes. Notice we just invoke draw shape and it draws with the current alpha and color in place. The low-level animation code invokes animate at fixed intervals based on EDT heartbeats. Normally, you would return true to trigger a repaint, but here I only want to repaint a specific component. Notice that I only change the angle and move every other frame to conserve CPU. Also notice I rotate by 0.1 degrees, which creates a very smooth, slow, and subtle rotation. This paint method belongs to the animation interface. We don't need it as we always return false. Once all of this is done, the login UI rotates in the background slowly and smoothly. A shadow appears after a second, and the UI looks, in my opinion, as good as the native UI.